Hello everybody, it is Mr. Condon. Happy Wednesday. So I'm going to start by making some videos. This assignment, the lessons 3 and 4 that you'll find in the chemistry remote learning folder. So if you go into the assigned work from March 16th to the 27th, 3 and 4, you have this chemistry packet. Most of us have been struggling with this, and this is what I'm getting the most questions about. So I figured I would go over made a video how to make these graphs using Google Sheets, and then two, maybe we talk through how to go about answering these graphing questions. I think for the remainder of the week, I'm going to keep making videos on this assignment because it is probably the most difficult one assigned to you and what I would like you to be working on if you have not yet. A lot of you have turned this in to me, but if you haven't, this is for you. So let's start talking about this. So we had this data table, right? And in the previous video, I showed you how to make a graph using this data table in Google Sheets. If you prefer, you can still make a graph on graph paper or on loose leaf paper, whatever works for you. But this I thought would be an easy way to do it. So here's our electronegativity graph for the first 20 elements. And here is our ionization energy graph. So let's talk about these graphing questions. I think we're going to do number 1 and number 4. So for number 1, based on your graph, so what is the trend, repeating your cyclic pattern, in ionization energy across a period down a family? So when we're talking about across a period, we got to go to the periodic table. Across the period means horizontal like this. Down a family means going down vertically, these columns. These vertical columns, they're called groups or families. The ones across are called periods. So across a period, down a family. Let's check out our evidence based on our graph. So we're looking at ionization energy, and here's our ionization energy graph. So it looks like as we start with these two, helium and hydrogen, our first two, let's check out where those are. So they're right here and right here. And then we go back to lithium, and then we go across that period again. So I think we're going to look at across this period, lithium to neon. Lithium starts low, 500, and then neon gets a little bit higher. So we're going up, 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 up. Ionization energy is increasing across the period. So I'm going to write that as my answer. And then as we go down families, let's go. So once we get to neon, if we look at our periodic table, here's neon, then we go back to sodium. And then we go across again to argon. So when we look at our graph, we see that sodium's a little bit lower than lithium, and then we're increasing again to argon. But ionization energy for the period above, the one that starts with sodium, seems to be higher, right? So as we go down a family or down a group, ionization energy is going to decrease. Decreasing down a family. That just means when you look at the periodic table, as you go down this family, ionization energy is going to decrease as you go down. That means it takes less and less energy to ionize an atom, right? That means to pull away an electron. It also means over here that it's really, really, really hard to pull away an electron and create a positive charge. So as you go up and to the right, ionization energy increases. As you go down and to the left, ionization energy decreases. That means it's really easy for francium to give up an electron. So the recording is going to stop in about 30 seconds, so I'm going to make another video answering number 4. And in number 4, we're going to use those trends to predict which element has the lowest electronegativity. So I'm going to stop this video, and we will make a new one.